In this lesson video, I'm going to show you how to solve polynomial equations from factored form. You should hopefully already have a copy of these notes printed out on blue paper. The learning target for today is that I can solve a polynomial equation written in factored form, and you'll know you'll be able to do that when, given a polynomial equation written in factored form, you identify each factor, write and or set each factor equal to 0, solve each resulting equation using inverse operations, and then finally write the final answer including all zeros, roots, and solutions. Before we begin talking about how to solve polynomial equations, there are a couple of key terms of which we need to remind ourselves. Remember that a polynomial is written in standard form when the exponents or powers, those are the teeny numbers on the variables or letters, are written in descending order, meaning they're written from largest to smallest, or greatest to smallest. You'll note that on the last two assessments, I've required you to make sure you write your final solution in standard form. Remember that a constant number, so a constant or a number that's all by itself, like 9, can be written as 9 variable to the 0, because anything to the 0 power equals 1. Now, what is factored form? This is something that may be kind of new to you, but you have been looking at factored form when we multiply binomials and polynomials. So when a polynomial is written in factored form, that means that it is written as a product, which means multiplication, of its factors. So basically, it's broken down as much as it can be broken down. You'll see a couple examples on the next page of what factored form will look like, but we should basically see a lot of parentheses, meaning there's lots of multiplication going on. Today, we're going to take advantage of the zero product property to solve polynomial equations. Now, the zero product property states that if the product, or what would result from multiplying something, of two real numbers is 0, then at least one of the numbers, or at least one of its factors, is 0. Now, written out a little differently, that means that if we have two numbers, we have A, say A and B, and they're both real numbers, which we're only concerned with real numbers in this class anyway. And if after multiplying them together, the result is 0, then that means either A equals 0, or B equals 0, or both equal 0. Basically what that's stating is if I have a bunch of things multiplied together and I don't know what they are, like A multiply B multiply C, but I know that in the end I get 0, that means at least one of these has to be 0. Because even if A and B are different numbers, like negative 18 and 2, as soon as I multiply by 0, meaning C is 0, my final result is always 0. So we're going to take advantage of that property to actually solve these equations, and we'll continue to be using this property throughout the next couple of months. Last piece of terminology here, roots. Roots are the solutions to a polynomial equation. They're also known as the zeros, which you've heard me say already. And when we graph these, which we'll do in Unit 3, they are the x-intercepts, or where the graph crosses the x-axis. So, you need to get comfortable hearing the terms roots, solutions, and zeros, knowing that they're all referring to the same thing, basically our answers. Let's talk about using the zero product property. Here are the steps that you will need to follow. Step 1 is to ensure that the polynomial is written in factored form. For this lesson video, all of the polynomials I throw at you will already be written in factored form. For the second part, you will need to actually factor first. Once it's written in factored form, you will then set each factor equal to 0, meaning you'll write a bunch of separate mini equations because we know that only one factor at a time has to equal 0 in order for the whole thing to equal 0. That's what the zero product property says. Then we will solve each resulting equation individually. And then finally, one of the most popular ways to write the answer is as a variable like m or n or p or r or x equal to a number, or you may write them in braces. I will demonstrate both today. Taking a look at the next page, you'll notice that the instructions tell us to solve each equation. They also ask us to check our solution. Just based on time, I'll probably only demonstrate checking the solution on a couple of these, but just know that you can and always should check your solution. So take a look at this first problem here. What I'm noticing is I have a variable outside a set of parentheses, all equal to 0. Now, I know that this polynomial is in factored form because I have two things multiplied together. I'm allowed to have add and subtract signs, but they have to be within parentheses in order for it to still be in factored form. If we use the distributive property to multiply this back together, we would get x squared take away x. So, now that I've identified that the polynomial is in factored form, I can move to step 2, which is to set each factor equal to 0. Here are the two factors in this particular polynomial equation. There is factor 1 and there is factor 2. So I'm going to write a total of two equations. The first equation will say x equals 0. Notice I just set the one factor equal to 0 because only one has to equal 0 at any given time. Now I will set the second factor equal to 0. The second factor is x subtract 1. Now that equals 0. You'll notice that the first equation does not need to be solved. It already says x equals 0. There's nothing to take away or remove. The second equation, however, is not yet solved. I notice that what's happening to the x is subtraction, so I need to undo it by addition. Whatever I write on one side of the equal sign, I need to write on the other. Drop the x down. 1 take away 1, or negative 1 plus 1 is 0. That cancels, and 0 plus 1 is 1. So my two solutions are x equals 0 or x equals 1. Here are the multiple different ways we could write this. We could write x equals 0, comma 1. That's probably the least writing. The comma signifies an or. We could also write it like this, x equals 0 or x equals 1. That's probably the most clear. Finally, we could use braces. If you're having trouble drawing the braces, you could turn your paper sideways and draw a little birdie, and then when you turn it right side up again, it should look hopefully like a brace. When we write our solutions, our zeros, our intercepts, in braces, we always write the smallest one first. So 0, comma 1. Let me demonstrate really quickly checking the solution. Notice that x could equal 0 or 1. This is the original equation. So I should be able to replace x with what it equals. So I'm going to erase and replace with 0, erase, replace with 0, erased a little too much there. On the outside I have 0, multiply. We work inside the parentheses first. 0 take away 1 is negative 1. I want to know if this actually equals 0. 0 multiplied by negative 1 is definitely 0. 0 equals 0. Since I have a true statement, I have a true solution. Let me back up a little bit. We should also be able to replace x with 1 and get the same thing. So we should have the same result. Notice nothing to do on the outside. 1 take away 1 is 0. Did what's in the parentheses first. 1 multiplied by 0 is 0. Once again, 0 equals 0. That solution works. You don't even need to write out the check part. You're more than welcome to just simply type it in the calculator. You would type 0, parentheses, 0, subtract 1, close parenthesis, press the equal sign, and as long as you get 0, you have the actual solutions. Let's take a look at the next problem. Again, this is already written in factored form, so I don't need to worry about considering whether or not it's in factored form. That will be the same for your assignment. The first factor is 3t, so I'm going to write an equation that says 3t equals 0. The second factor is t plus 2, so I'm going to write a second equation that says t plus 2 equals 0. Now, notice neither of these equations are fully solved yet, so we have some work to do. I see 3 multiplied by t, so I'm going to undo that by division. Whatever I do to one side, I must write on the other. I'm going to drop down that t because that's all that's left. It's 1t, a single t, and 0 divided by 3 is 0. Looking at the other equation, again, it's also a one step. I see a positive or adding 2, so I'm going to subtract 2 on both sides to undo that. That's the inverse operation. Drop down the t, those cancel, drop the equal sign. 0 take away 2 is negative 2. So my two solutions are negative 2 and 0. So t could equal negative 2 or 0. I could also write that like this. There are probably other ways to write this, but these are the three most common ways to write the solutions to polynomial equations. Final way to write this, that's a poor brace. There we go, negative 2 or 0. Take a look at the next one. You'll notice this should look very familiar because it looks like the binomials we were just multiplying together on the last assessment. I know though it's in factored form because I don't have any plus or minus signs in between parentheses. They're okay within the parentheses. So my first equation should say z take away 4 equals 0. The second equation I should write as z take away 6 equals 0. You'll notice both of these are one-step equations we need to solve by adding or subtracting. In this case, since they're both negative or subtract, we're going to add on both. So whatever I write on one side, I better write on the other. I'm going to drop the z down in both cases. The other number will cancel out. I'm going to drop the equal sign. 0 plus 4 is 4. 0 add 6 is 6. So my two solutions are 4 or 6. I may write that as z equals 4, 6. Z equals 4 or 6. Or brace 4, 6, close brace. Another way, of course, you could, if you really like doing lots of writing, is write z equals 4 or z equals 6. So that's another option as well. Just make sure that your answer is clear and that it contains all of the solutions. Let's try one more time here, checking our work. Actually, we'll check the work on the next one. Looking at the next polynomial equation. There's my first factor, there's my second factor. This is one of those special ones that if we multiply it out, we lose that middle term. Because you'll notice it's the same thing before and after the plus minus signs. One's positive, one's negative. So there's me setting the first factor equal to 0. They're setting the second factor equal to 0. These are going to be two-step equations to solve. Remember, we move what is furthest from the variable first. So I see a 2, I see a 7. The 7 is further away, so I need to remove that first. It is positive, so I'm going to subtract it on both sides. Looking here, the 2x should get dropped down. Nothing to do with that yet. Those cancel, drop the equal sign. 0 take away 7 is negative 7. Finally, I need to remove the 2 by division because that's multiplied right now. That cancels and I get a single x, 1x. Here, go ahead and type negative 7 divided by 2 in your calculator. You could also use that n over d button and type it as negative 7 over 2. And you'll notice that the calculator does not simplify that result. If you do the division, it might tell you it's negative 3.5, which is correct, but it's best if it does not simplify to become an integer, i.e. if it's a decimal, you should leave it as a fraction, negative 7 over 2. Looking at the second equation, I see that I need to move the negative 7 first because that's furthest away. I'm going to do that by adding 7 on both sides. Drop down the 2x, that cancels. 0 add 7 is 7. Finally, I need to remove that 2 by division because it's being multiplied. What remains is a single x, Once again, 7 over 2 or 7/2 does not simplify, so I'm going to leave it as such. Again, multiple different methods of writing the answer, the solutions, the roots, the zeros, but we could write it like this with a comma in between each solution, zero, root, intercept. We could also write it like this with an or. Again, the comma just means or anyway. Or we could also write it in braces. -7/2, comma, 7/2. Notice this is different from a point, right? Because points use parentheses. The braces tell me those are solutions, or zeros, or intercepts. I'm not going to show you exactly how to solve this one, but I do just want to point out really briefly that this power of 2 tells us that this whole thing that's in parentheses repeats twice. So your two equations are this and this. Now you will notice that you will get the same result from setting each equal to 0. X will equal 1 on both. And no, you do not need to write it twice. So you would not need to write something like that. Instead, that would just suffice. Go ahead and take a look at this next one. You'll notice here we have now 3 polynomial equations. So we have 3 factors. We have one polynomial equation with 3 factors. So we must set each factor equal to 0, regardless of how many there are. The first will say x plus 1 equals 0. The second is x take away 3 equal to 0. And the final is x take away 2 equal to 0. Wow, we have 3 equations to solve. Thankfully, each of these are one step. This one I'm going to undo by adding. Same here. And here I will undo by subtracting. You'll notice on each of these, you'll be able to drop that x immediately down. And then the equation is practically solved. We will also drop the equal sign. You'll notice cancel, cancel, cancel. 0 take away 1 is -1. 0 add 3 is 3. And 0 add 2 is 2. Here when I'm writing my solutions, the least value is that -1, then 2, then 3. This one would require a little more writing if we actually write our solution out in different ways. So we would say x equals -1, 2, or 3. Or -1 or 2 or 3. And then finally we could use the braces. The braces are nice when you have multiple solutions. -1, 2, or 3. What I'd like you to do before you take a break or move on to the second lesson video is go ahead and try this on your own. These ones are a little more difficult. Notice there are 3 equations, so you would need to, or 3 factors, so you need to write 3 equations. If you'd like to pause the video for a second and then check your work, that may not be a bad idea. Okay, each equation should look like this. 3x take away 4 equals 0. 2x add 6 equals 0. And then finally, x take away 5 equals 0. I'd like you to now spend a couple minutes solving each of these equations. I'll give you a hint and let you know that this one is going to be 2 steps and it does not simplify, so leave it as a fraction. 2 steps and it does simplify, so do type it in your calculator. And then that one's a single step. Really quickly, I will demonstrate solving these. I need to add 4 on both sides because that was a subtract. This one is also going to start with addition. This one will start with subtraction because that's an add. Looking here, I'm going to drop the 3x down, drop the 2x down. And on this one, I'm going to drop the single x down. They cancel, cancel, cancel. Drop the equal sign, drop the equal sign, and drop the equal sign. 0 add 4 is 4. 0 take away 6 is -6. And 0 take away 5 is 5. That last equation is fully solved, but these other two are not quite yet. We need to remove that last number there by dividing, because that's the inverse or opposite of multiply. Notice here, if you type 4 divided by 3, you would get 1.33333. So that doesn't simplify. You could also try the N over D button and notice it doesn't simplify again. Here though, -6 divided 2 does simplify nicely for us. That becomes -3. And then we already have x equals 5. Now here, it may not be obvious when you go to order. It does not necessarily always, it's not always true that the fractions are smaller than the whole numbers. Like if that was 15 over 3, it would be equal to 5. So if it was 16 over 3, it would actually be larger than 5 and would pop over there. So just because it's a fraction doesn't mean it comes at the end. But there's one option for writing your solutions. I'm going to skip the one using the word or because that's my least favorite. My most favorite is writing it in braces. Hopefully that gives you an idea of how to solve polynomial equations from factored form. Do go back and try this problem here that we didn't do if you have the time. You could also practice checking your solutions by typing this in the calculator where you see x. This would be a little more difficult though on some of those more complicated problems. So I hope you are feeling confident in solving polynomial equations written in factored form.